Hello and welcome to section 2.1b. In this section we're going to, these video notes we're going to do a little bit of review of what we talked about the other day, but this time I am going, there's a little bit of a kink in it because there's a negative in front of the x squared. So in order to find vertex in line of symmetry, you're probably thinking, hopefully you're thinking, completing the square. And so that's what we're going to do. We're going to complete the square on this, but with this negative out in front, just like when we were in class, we moved a 2 out front, we're going to have to factor out this, this negative right here. And so this is going to get kind of ugly with the 5 and the negative and whatnot, but we're going to factor out a negative. And so now to complete my square, I've got x squared minus 5x. And remember, I just leave that 4 alone. So I'm looking for this blank space in here. And so now I got to figure out what am I going to add on. So to turn this into a perfect square. So I take the middle term, the b term, divide it by 2. Well, that's the best I can do for dividing it by 2. So then I'm going to square it, which gets me a positive 25/4. Now that's kind of an ugly number to be adding on, but it is what it is. So we're going to add that on, and we're going to add it on over here. Now, not going to add it. Hopefully you caught me on that, and yeah, I'm actually going to subtract it because I'm adding it here, which changes the function, and so I'm going to have to subtract it out here. But now, be careful with this. Actually, I was right, but with this one, because I have negative 25/4, which is what I should have there, 25/4. Remember that this 25/4, even though it's being added, is getting multiplied by -1. So this negative 25/4 actually has to be multiplied by +1 to keep it in balance with what's actually happening. Because of this -1 multiplying the 25/4, this positive version, it's actually a negative that's being added. So over here, the negative 25/4, which I should be subtracting, also gets multiplied by -1. So if that's not clear, please ask in class when you come to class. So I'm going to get something like this: -1 x squared minus 5x plus 25/4. And then on this side, this is really -4 plus 25/4, which is what I said originally. And so now I have to complete the square on this, so I have to factor that. And hopefully you've noticed that there's a little bit of a pattern as we've been factoring these things, that when you go ahead and factor any of these, that whatever this factors out to, it relates to this number right here, the -5/2. Well, that is what I would multiply. That -5/2 is what I multiplied by itself to get the 25/4. So that would mean that my two terms, when I factored, are going to be both -5/2. So I've got x minus 5/2 squared would multiply out to get me this thing right here. And you can multiply it out if you don't believe me. And then over here, I've got to get common denominators. So this 4/1 needs to be multiplied by 4 top and bottom, which then means I'm subtracting 16/4, which is still the same as that 4, plus the 25/4, which is what I had before. So combining these guys together, I have 9/4. So my final function of this will be x minus 5/2 squared plus 9/4. And so there, my vertex, which is kind of an ugly vertex in this case, but the vertex that I'm looking for is going to be the opposite of what I see in here, 5/2, and exactly what I see on the outside, 9/4. So there's my vertex. And remember, the axis of symmetry comes from the x value of the vertex. So my axis of symmetry should be x equals 5/2. Now, even though completing the square, this was a review, I did all kinds of different things. We dealt with fractions and the negative, and so it was a little bit of a review, but it's a lot of new stuff in there. So please come to class prepared to ask your questions. In the next one, we're going to have to go through and find the x-intercepts of the following. And so we're trying to find out, when it's asking for the x-intercepts, think about these. These are parabolas, and we're talking about a parabola that may or may not, like for the first one, is going to open down because it's negative. And so we're looking for, where is this graph crossing the x-axis? Now, that's not the graphing one. That's the last one I'll do down here. But I'm going to have to factor this. And so if I'm going to factor this one, the first thing I'm going to do is I don't like that negative out front, so I'm going to factor out a negative 1, which will get me x squared minus 6x plus 8. Now I'm looking for 2, so I look at my 8 here, and so I'm going to kind of undo this by the distributive property, and so I am looking for factors of 8. So my factors of 8 would be either 1 and 8, 2 and 4, and that's pretty much it. And since they have to add together to get me negative, both of these guys need to be negative. So which of these guys, when I add them, because there's an add sign, which of these guys will give me negative 6? Well, that's the negative 2 and the negative 4. So I'll leave the negative 1 outside, but I'm going to rewrite this middle term as negative 2x and negative 4x, because that's still my x squared. So I've got x squared minus 4x minus 2x plus 8. So I've rewritten that middle term. I just broke it apart using these factors. So now I'm going to undo the distributive property by putting parentheses around my first 2 terms and my last 2 terms. And so now I'm going to take out my greatest common factor. And so you'll notice that as I do this, I am undoing the distributive property, which is what we are doing when we're multiplying binomials together. So you'll notice that I have an x in common, so I'm going to factor out an x, and what I'm left with, if I was to distribute the x to this parentheses, I have to have an x and a negative 4. Well, in the second set of parentheses, I also have a number in common, and in this case, it's going to be negative 2. So I'm going to factor out a negative 2, and when I factor out a negative 2, I'm left with x minus 4 again. So you'll notice now I have 2 sets of parentheses, x minus 4 and x minus 4, that are identical to one another. So that basically means that I factored correctly. So the first term is x minus 2, and the last term is 1 set of parentheses of x minus 4. So to finish off my factoring, I get 1 times x minus 2 times x minus 4. Well, how does that equate to finding out what the x-intercepts are? Well, what does it mean in my graph when we're looking at the x-intercepts? Well, that means x-intercepts, the y value has to be equal to 0. So this was a function, and so I'm going to set it equal to 0, and if I solve this, that would get me, I would divide by negative 1, so that goes away, and so really I'm left with 0 equals x minus 2 and 0 equals x minus 4, which I can break up using my zero product property, which basically says 0 equals x minus 2 or 0 equals x minus 4. If I add the 2 and add the 4 across, the x-intercepts for that one are 2 and positive 4. That's what I was looking for this problem, the x-intercepts. Now if I'm going to use the quadratic formula for this, remember the quadratic formula does the same thing, gets us the x-intercepts, and it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, we just have to pick apart what we've got up here. A is 2, b is 5, and c is negative 3. Now I don't have enough room for this, so I'm going to move over here and plug it in. So x will eat and substitute it in. So I'm going to substitute in 5. So I'm going to have negative 5 plus or minus. Now I'm going to put 5 and square it automatically and just put 25 just to speed us along here. 4 times a, which is 2, and then 3 is, or it's negative 3 for c, all over 2 times a, which is 2 times 2. So continuing on here, we have negative 5, and now it's just a matter of simplifying this. 25 minus, well, let's see, negative 4 times 2 is negative 8. Negative 8 times negative 3 is positive 24, I believe. And all of that is over 4. So my final answer for this, my final 2 answers for this is, oh, well, that comes out kind of nice. That's 49, right? 25 and 24 is 49, which is a perfect square, which means that this is crossing the x-axis at pretty much at a whole number, because I can take the square root of 49 and get 7. So I thought I was done until I saw that I got a perfect square underneath my square root, and so negative 5 plus or minus 7 divided by 4. So if the final step is to break these into 2 separate equations, that x will equal negative 5 plus 7 over 4, and x will equal negative 5 minus 7 over 4. Well, if I add 7 to negative 5, I will end up with 2 over 4, which is 1/2. So it's crossing the x-axis at a half. On this one, I get -12/4, and that means it's crossing at -3. So the two places, the two solutions to this problem, the two places the x-intercepts are at 1/2 and -3. So as ordered pairs, -1/2, 0, and -3, 0 would be, or it's 1/2, 0, and -3, 0 from my solutions that I have here. And so then the last one is graphically, so I need to get a graphing calculator. And I'm just going to graph this and try to figure out where they cross the x-axis. And so I need to clear out my graphs. But it is 4x squared. Like something like that, and I will go ahead and graph it. Now you can see that this is a parabola. Since 4 is positive, I know the thing's opening up. I could zoom out and see the bottom of the parabola, but I'm not going to because I really need where it's crossing the x-axis. Those are the solutions I'm looking for. So what I'm going to do is I'm going to follow some steps here, and I'm going to do second trace, and I need a 0 where the thing is crossing the x-axis. So I'm going to 0, and it says left bound, so now I got to just find my cursor. Where's it at here? Do you see it? I don't see it yet. So I got to go to the left of one number. There it is. So I'm going to the left of one of my zeros, hit enter. Now it's asking me for the right bound, so I'm going to go to the right of it. And then it says make a guess at it, so I'm going to get as close as I can to it. And so I'm going to make a guess, and it looks like one of my zeros is -7, 0. Alright, so I'm going to do the exact same thing again. Go second trace, which I'm looking for a 0. So I'm trying to figure out where it's crossing the x-axis. This time I'm going to go to the left of it, which happens to be below. If I can get my cursor to show back up. Let's see what's happening here. There it is. Oops, there it goes. So there's my cursor. It's to the left of it. Hit enter. I'm going to go to the right of where it's crossing. Hit enter. And then I'm going to try to 0 as close as I can to it. Looks like one of those guys. And so you can see that the other 0 for this function is 0.750. So those are the two solutions that I'd be looking for. -7 and 0 would be one of my x-intercepts, and the other one would be 0.75 and 0, or 3/4 and 0. And obviously you could use the quadratic formula or possibly factor this if you like to get these zeros also. It's just multiple ways of doing the same thing. So this concludes our videos for today. If you have any questions, please come to class prepared to ask them.